Hello everybody, and welcome back to the Poor Man's Chemist. In this video, I am going to do a couple of very simple, easy little preps of some compounds that I'd read about on atomistry months ago, and I put on the list of compounds to make, and I just never gotten around to them because they're very quick and very easy, and I was saving them for when I needed a quick and easy one, so this is going to be them. I'm going to give you a quick update first on the potassium tetraarsenite that I made in the last video. After sitting for a while where all the alcohol could evaporate, it turned into a clear syrupy liquid, and I mean, syrupy is exactly the way to describe this shit. It's like molasses. I finally got sick of hoping it would crystallize just sitting out, and it's been in the desiccator, and it's starting to. There are some little chunks in it. I don't know. It keeps almost like it looks like it's decolorizing a little bit as it crystallizes, but there are a few little ones there. It takes its sweet ass time about it though. Anyway, I just want to give you an update with that. The first one that we're going to do is Thallium Uranyl Carbonate. Apparently, this was used as a test for microchemical detection of uranium or uranyl ion, according to atomistry anyway. All I have is just the basic formula of this, which is on the screen there. I am going to combine everything in stoichiometric amounts, and we're just going to see what happens. It doesn't give me a color the precipitate's supposed to be. I imagine it'll be kind of uranyl-ish. In other words, kind of yellow, greenish, something like that. So here we go. Let's start with thallium sulfate. Add that in there. There we go. Get in there. And my perfectly sized stir bar for this beaker is stuck in the potassium tetraarsenite. Ooh, this one might be too small. Yep, we have stir bar inadequacy again. This keeps happening. Well, you know when they say when you get older. No, honey, I promise this never happens, really. Shit. Break shit. Alright. There we go. Okay. Listen, you don't go flinging that shit out of there all over me. I don't want thallium sulfate all over me. Thank you very much. I like my potassium channels just the way they are. Alright. Let's give this a little heat here and let it dissolve. Thallium sulfate is fairly soluble, but it takes a minute or two to actually go into solution. So, and we may need to actually warm it up because it's soluble, but it's not super soluble. I don't want to go overboard on the water. I'd like to keep everything small. Makes it easier to recover the final product when we're not going to make a whole lot of it. Because even if I'm working from uranyl acetate dihydrate, and even with half a gram of that, it takes 2.38 grams of thallium sulfate, or put it another way, half of my total thallium sulfate. So yeah, this is an expensive experiment, both in money and time and effort, because making thallium sulfate is kind of a pain in the ass. And making it from recycled thallium never seems to work out well. Probably because of impurities trapped in the recycled thallium. Okay, you can dissolve any time now, you odious cunt. Okay, well, apparently a little bit of my thallium sulfate was an acid salt, because when I added in the sodium carbonate, I got some fizzing off of it. I don't think the carbonate has to be stoichiometric. I'm not sure. Uranyl salts do like to dissolve in excess carbonate. I don't know. I added a little bit more in there. So we're going to see what we get. All right, now have a solution of uranyl acetate that is very hot. Ow. Oh, looks like it all worked perfectly. I guess. I don't know what color it's supposed to be. But yeah, that looks about reasonable. It did precipitate right out, and the solution is pretty hot. Interesting. Well, let's shut down the stirring, take off the heat, and let's see. Survey says, oh, nice. Oh, yes. Lovely. That looks like it pretty much precipitated quantitatively. Words. Huh. That was pretty goddamn easy. And pretty cool. That was neat. Boy, it is showing up as a much more vivid yellow on the camera than it is in real life. In real life, it's more of, I don't know, kind of a lemon yellow. It's a lighter yellow color. But it's very sparkly. Huh. Very, very sparkly. That is so damn cool. That is so damn neat. That is fucking cool as shit. Alright, well, on to the next one. Alright, for our next compound, we are going to do uranyl hypophosphite, which should be very, very easy to make. This is uranyl acetate. There's 1 molar equivalent here and 4 molar equivalents of sodium hypophosphite monohydrate in here. And this should precipitate out. Oh, but it didn't. Now that's curious. Why didn't you? Now, atomistry said that it was soluble in excess of the reagent, but it specifically said to use 4 equivalents of hypophosphite. Interesting. Well, atomistry said it's made by agitating these solutions together in these exact proportions. For once atomistry gives us like a ton of info, I would think that if there was too much hypophosphite, we would have seen a precipitate earlier that would have dissolved. We never saw a precipitate of any kind. But it just says that these solutions need to be agitated together. But, of course, it doesn't say how soluble it is. Nah, because that would be too easy, right? Well, we can try evaporating it down a little bit and see what it becomes. And if it doesn't do anything, we can try adding nitric acid to it because, according to atomistry, uranyl metaphosphate is made by heating the precipitate that you get from uranyl hypophosphite when you add nitric acid to it. So, well, let's heat it up and let's see what this shit becomes. Try evaporating it down, and if it still stays in solution, we'll figure out a plan from there. Okay, it took some stirring and a little bit of heating, but it finally kicked off, and now we've got uranyl hypophosphite. Cool. Well, fuck it. Let's add some nitric acid to it and heat it and see what it does. I have no idea how much it takes. I don't know when the reaction's finished. I don't know what uranyl metaphosphate is supposed to look like or what the fuck it's supposed to do. So we'll be plowing into the unknown. Like any other day on this channel then. Okay, so we're going to give this a go. It's almost turning a dirty yellow, almost kind of brownish color. It looks a little ugly. Let's see if we can't improve it with a little HNO3. All right. Well, that did something. I'm not really sure what, but it's something. Interesting. I have no idea if more is good or not. Huh. Well, atomistry did say it was kind of a yellowish green precipitate. I guess you can kind of tell yourself that's what that is. I don't know. Let's add a little bit more and see what it does. Anything seems to make it go even clearer. All right. Well, looks like atomistry gave us one winner and one dud today. Well, let's heat it up. See what it does. Okay, well, this is very curious. Some kind of green compound started crystallizing out on the stir bar. There were some decent-sized chunks of it here that unfortunately got smeared by the goddamn forceps trying to pick up this thing. But they were distinctly little blobs, kind of like that. Oops, there we go. There's some kind of green compound. Now, oh, shit. Now, atomistry did say something about this stuff being a greenish yellow. That's kind of greenish yellow. Yeah? I don't know. Keep going with it and see what it does. Wow, this is an interesting development here. So as I was heating this stuff and stirring it, it all of a sudden started precipitating out this yellow compound. The green compound that was stuck to the stir bar changed to this, and as it's cooled, more has precipitated out. Considering that atomistry said that the precipitate produced by the nitric acid on the uranyl hypophosphite was supposed to be a green, I think they said it was either yellow green or greenish white. I can't remember. I think it was yellow green. I mean, they don't give a color for uranyl metaphosphate, but I mean, there was a color change. We've got this. I don't know what else it could be. So, I mean, I'm going to save this compound, and I'll try to come up with some way to test it to try to be sure that it isn't, you know, what I think it is. But I'm reasonably pleased with this. This was a bit of trailblazing here, so I'm going to go ahead and wrap this up. If you liked that video, give it a thumbs up, and if you didn't, well, whatever. Subscribe, comment, share the video, donate a few bucks if you can, and until the next one, y'all, I'll see you later. Pretty goddamn cool, really. No way to test it.